Sir, that other astrophysicists have said that we now have sound for astronomy. And it sounds, well, exactly like this.
Well, you gotta explain that a little bit. Most of that is noise.
And that
Shh is noise.
right.
And the signal is the boom. Or the boop.
Right.
So I think you've repeated it there so that you can hear it multiple times, right? This happened actually only once. The signal lasted 0.1 milliseconds actually.
Yeah,
Sorry,
I mean,
1.1 seconds.
but astronomy now has sound?
Well, more or less. So it's an analogy. The idea is that astronomy has been deaf so far. All we've known about the universe so far has come from images, okay? From pointing different telescopes at things that emit light at different frequencies. And so you take that light, you detect the light, you create an image. Great. Now we know that there's N stars going around, you know, different objects and whatnot. But this is not a light wave. This is a gravity wave, okay? And like, and these waves propagate through everything, interacting essentially with nothing as they go through. So unlike light, gravitational waves don't get absorbed. So they're transparent to, as far as they care, there's nothing between us and the black hole. They just go through. And that's also why they're so hard to detect, because they're also not absorbed by Earth or our instruments, so you have to build these incredibly precise machines to be able to see them. But that's great, because if you do see them, that gives you a very pristine image, a very pristine information of what the source that produces gravitational waves are. And so because the waves happen to be, happen to look like a sound wave, if you actually draw them on paper, and because the frequency of those waves happens to be more or less within the hearing range, you can play them. You can tell speakers to vibrate exactly like the wave you drew on the piece of paper, and that will produce a sound. And that's the sound that you were playing. It's not a sound wave in the same way that we hear of sonic. What is a sound wave? A sound wave is vibrations in the air that move longitudinally. Gravitational waves are not vibrations in air.
Oh, okay.
They're vibrations in gravity.
Okay, that you just blew my mind.
Well, gravity, electromagnetism, okay? So electricity, radio, okay, and television. We communicate through the transmission of electromagnetic signals. That's how radio works. Okay? And what do these electromagnetic waves propagate in? Well, they propagate in air for us because we live in an atmosphere. But they also propagate in space, and there's no air there. So clearly air is not the thing that's moving to allow the waves to travel. It's the electromagnetic field, if you want.
Yes.
And similarly, when gravitational waves propagate, it's the gravitational field, or the gravity itself, that's vibrating. And remember, earlier on in our little Fun with Physics series, we talked about how gravity was a curvature of space-time. So if you think about it in terms of space-time, it is space-time itself that's vibrating. It's lengths and times that are contracting and expanding as these gravitational waves go by. And it sounds like science fiction, but we've actually measured it. So it's not science fiction. We've detected this thing, and other people have detected the same thing somewhere else. One group in Louisiana, one group in Washington, and it's as solid as an observation can be.